Okay, we are live again, and this time, as the last time, my name is Jonathan Wollmender, and I have with me my friend Kenneth Franzén. Hello.
Hello, everyone. So, we are back for a new episode to show the basics of the wonderful program that you've been a great part of creating. What will we have a look at today?
Today I thought we should look at textures. There's a lot of stuff you can do with textures, and how VSXu can handle textures, load them and modify them and squash them and stuff.
All right, sounds exciting.
So, yeah, where should we start?
Some form of output, I guess.
Yes, we should first look at how to, maybe we covered that slightly in the last episode, but how to just debug and look at a texture. And for that we need this module, which I just created here, textured rectangle. It's the sibling to the colored rectangle, which we covered in the last episode. And we connect that, and it's black because it doesn't have a connection in yet. It's no texture. So if we look in the module list over here, or we can look here as well, texture, this area, we have a particle generator called blob, which is a very useful all-purpose test module for textures.
With a wonderful name.
Yeah, it creates a blob. I don't know what else to call it. It's a blob.
Yeah, true.
And I'm moving faster this time with showing stuff, because you should have watched the first episode, so you know how the interface works. And we will just quickly cover a few parameters of this module, which is really useful for a lot of things. You can always find this blob module in my presets, because it's so useful for a lot of things. For instance, it can create a star.
Ooh.
Like that, and the attenuation sets how crisp it is. Let's go full screen with that instead. And it has some more star flower, for instance, creates a
gap between the arms. All right.
Yeah, it's a division error actually. We will increase the resolution of the texture now.
All right.
Now it looks better. And of course, the generation is much slower now because the resolution is much higher.
Right.
So that's just a hint. You should never connect anything to these parameters unless you know what you're doing. And internally, this bitmap is generated in a thread, so it's still as fast as possible, but it takes a while for the CPU to generate this high-res texture. Just so you know. And you can do stuff like set the color. And now another thing. We clone that, so we get another copy. Then we connect those, and we move that one. You see, it's not really opaque, or it's opaque.
And you can't see the other one through it, right?
Yes, so we enable alpha, and then you get that. So now I know that frame rate on Google Hangout is quite bad, but for me it's smooth right now when I'm moving this. So this is rendered on the graphics card. So this is uploaded. This blob module here uploads the texture to the graphics card. So once it's generated and it doesn't have to do anything more, it's really fast on the GPU. Okay.
Right.
Maybe also as a next step, we should look at blend modes, because this comes up a lot when doing this. This is in the renderers, because this is an OpenGL blend mode. Maybe you know of blend modes in Photoshop between layers, or in the GIMP for that matter. You have different blend modes. OpenGL has only a few, and to tell the truth, I seldom use more than 2 of them. The other modes are useful in more advanced scenarios, perhaps, but the ones you have a lot of, you can play around with this also if you like. And now I picked 0, which means it doesn't draw anything. But the most useful one is either to set the dest blend to 1. Did you see what happened?
No, not quite.
Okay. Let's make this one white. It'll make it more obvious, I hope. Or maybe this is a bad texture to use. Actually, you know what? We will disable the alpha. 1 minus source alpha. That's the original one, right?
All right.
So now that it still has no alpha value. The alpha value is still 1, so it's black in the borders. But then you can go like that, and then you get the same kind of effect, but not really, because the values here, if you see where I have the mouse cursor,
right,
those are added up to white. So if we, for instance, you make this one red and this one green, and we overlay those, you get yellow.
Yellow.
Or
Ooh.
Yeah,
nice
whatever.
Effect.
Yeah, looks good. I've never done this before.
Very hippie 70s.
Yeah, perhaps. Yeah, whatever. That's nice.
Psychedelic.
And
go for it.
You can also do DSD alpha. Yeah, sometimes these are useful. Source color. Yeah, just play with them. Source alpha saturate. Yeah, I don't know. So this is a bit of OpenGL shining through here with all its complexities, but at least source alpha 1 or 1.1 is really good to know. And then you can read the OpenGL docs for more fun stuff with that module. Okay, you can do a lot more with this blob if you like. As we just said, I have never seen this before. This was an accident. Today's happy accident, which is kind of why I still like playing around with this program. Oh, here, maybe texture coordinates. Does this make sense at all? Maybe not so much. Okay, let's disconnect one for now. So we have only one, and that too. There is a bunch of modules which control the texture matrix in OpenGL, and that's also really handy.
All right.
Translate, scale, and rotation. And textures do these things. That's what they are for. Rotation, scaling, and translation. And a few more things, but not in this aspect. So, okay. Now these are applied over here. So the blob is still the blob. Nothing happens in there. But these all add something to the texture matrix, which will then happen over here when it's drawn.
All right.
And you can do stuff like this, translate.
Whoa.
And so on. And scaling is really nice. Let's show that by using the maths converters float to float3 module. Makes it easier.
Okay. Whoa.
So it's scaling on the graphics card. And you can rotate.
And it rotates around what axis?
Right now, the z-axis. So inwards. Imagine the axis going inwards the screen.
All right.
You can rotate around the x-axis, and then you get strange effects like this, or both, and get really wonky.
Yeah, that looks almost broken.
Yeah, but sometimes this is useful.
All right.
I can show a trick actually while we're at it. If we set this to like 16 and attenuation, and we remove and you can scale like this. This can be really useful actually for later use. Yeah, anyway. Translation, you can do elevator effects or stuff like that.
All right.
Depends on the texture. And I think we messed over here as well. Yeah. So that modifies the angle of the rectangle. Do you have any questions about these three: rotate, scale, translate?
Yeah, I have a silly question, or a stupid question perhaps. Which part created all the copies?
That's the scaling one.
So scale creates more than one.
No, there is a reason for this, and we need another module to show that.
All right.
It's called texture parameters. Let's reconnect all these things. First, take a look before what it looked like when we scaled.
Right.
Okay. So if we now disconnect that and bring it through the texture parameters, and we look here.
Same.
Yes, we have two modes for S and T here. That's the local coordinates in the texture space. So basically, it's X and Y.
Okay.
So here we can say that we should clamp. Okay. So now we barely can see it, but
it's only one.
Yeah. And we can then translate it to the center, hopefully. Like that, yes.
Somewhat, yeah.
And then there is border color you can set. Or no, we should clamp to border for that.
Whoa. Huh. Now you can see the plane that it's projected on.
Yeah. And we seem to have found a bug also. We can only make a red border color, but border color is not really that useful anyway, so.
All right, interesting.
And we can also set the texture, the filter here, which we can set to nearest, which is not obvious right now because the resolution of the texture is way too high. So let's do that, and let's make this slightly larger. And then we set it again to nearest. Okay, there we go.
Hey, Minecraft.
Now it looks like Minecraft. Yes. 2 points to you for that. So this is how you make crappy textures for Minecraft. No. Okay, but these things still work, and you can. We should enable the repeat again. But another one which can be quite useful is mirrored repeat.
All right, what does that do?
Yeah, we will look at that when we play with some of the generators.
Okay.
So let's do that. There is another branch of the VSXu module tree called bitmaps. And you might say that a texture is a bitmap on the graphics card. But the bitmap is not on the graphics card at all. It's in the CPU area. So bitmaps is just a preparation stage until you make a texture out of it. And for that we need this module called bitmap to texture. It takes a bitmap in and a texture out. And to repeat this, we take the blob again, because there is a blob bitmap generator.
Oh, all right.
It's actually the same module, but it does the exact same thing. So why do we do this extra unnecessary step, you might ask? And the reason is that there are lots of more bitmap generators. And these are to be thought of as not moving, you shouldn't control these with parameters. Like these shouldn't be, they should only be set by hand. And it becomes, we will increase the resolution a bit of that one. And I actually think we should remove all this clutter that we have created. Okay.
Ooh.
Too large. Now this is these ones are no longer. Well,
Not
that
connected.
one is. Whoops. Now.
Right.
Now we have a clear path here. So the blob goes through the bitmap to texture and then to the textured rectangle. Let's remove the blend mode also for clarity.
Right.
So it's only 3 modules. Okay. Let's make this one white also, because it was this one coloring it, and that will cause problems for us later. So now let's create filter. Let's see, overlay we can use, for instance. And then we can use the perlin noise bitmap generator. So let's disconnect that. And this one takes 2 bitmaps as input.
So you take the blob and
yeah,
the new one.
I mean, we need to, this one by default works with the size 512. You can increase that, but let's for now make it easy for ourselves. So we set these to generate bitmaps that are 512 by 512.
All right.
Now we can connect those.
And we'll get 2 blobs.
Yes, this is because the octaves are not that high of the perlin noise. Now you see something different.
Ooh, now it's a cloud.
Yeah, and it is. You can set the opacity here, so that's how much they will affect each other. And here, now you can select, there are shortcuts to all these modules, but you can also, while you have created it, change the blend mode. And some of these you remember from Photoshop, probably.
Yeah, right.
Lighten, for instance, that looks rather nice. But I think we should put these in the opposite order. So the perlin noise first, and the blob second. Okay. That
Whoa.
looks really strange, but I think I know why. Yeah, we are adding more than one, then you get these.
Rorschach test. No, it looks like it's burning.
Yeah, strange effect, but
cool.
It you can do lots of unwanted stuff with this, but it still works. It's just what do you call overflowing? I think the values are too much.
All right.
So let's set multiply, and then let's say big attenuation. Like that, and I think previously we made this red.
Beacons in the dark. All right.
Yeah, that looks kind of nice. And then we can also set the overlay here. Maybe we can we can set exclusion no, color burn.
Ooh, radioactive cloud.
Yeah, blend glow. That's some special one.
It reminded me of the Xbox logo, the first one.
This one.
No, the previous one.
This one.
Yeah, you see
Yeah.
the X, right?
Maybe. So let's make it blue instead.
Yeah, that's better. Thank you.
And we should also mess with this one, red. Oh no, we are really. Yeah. But anyway, this is very useful to create textures for later use. So just play with this. As you see, we are doing that right now, and we are getting all sorts of fun effects. Then also you can chain these. So let's clone that. And what do we want to do? I think we want another blob probably. And what mode did we have? We had glow. We want to add something. We can rotate it a bit. Yeah.
Okay.
So now this is a compound image of 3 generated bitmaps.
Yeah, right. One is just the cloud noise, and there are 2 stars.
Yeah.
Or blobs.
And multiply it as black. Yes.
Ooh.
Subtract. Yeah, I don't know. Screen.
We're wandering into thunderstorm territory here.
Maybe, yeah. Yeah, so there we go. Something. Bitmaps. Do you know what that is?
A bitmap? No?
Yeah. It's it generates when you're playing around like this, it might actually slow down things, but I don't think you can notice it. But it creates several copies of the texture internally on the graphics card with different sizes. So when you make it smaller like this, or even that small, it creates several different scales of it, so it always looks nice. And it can also help optimize some things, but that's only if you have really heavy scenes that make a lot of use of this texture.
Okay.
So to recap here, these modules are all happening on the CPU. So let's show you that again. These modules, the bitmap modules, are all happening on the CPU. So be careful with connecting stuff to them. It will really be slow. And so on. So if we now really want to do stuff like this, but on the GPU, that would be nice, wouldn't it?
Yeah.
There is a module for that.
Of course. To paraphrase
But maybe
Apple.
first we should take a look at how to load external files. For instance, there is a module that loads JPEGs and one that loads PNGs.
So you don't have to create your bitmap image.
No. But that can still be fun and useful because it will really make small projects. Your file will be 1 or 2 or 3 kilobytes compared to 3, 4, 500 kilobytes if you added a JPEG image to it.
Cool.
So when you design music visuals, it's really preferable to use these tools up here. And the perlin noise module is really useful to create clouds and nice glow on spheres and whatever.
Yeah, I can imagine.
That algorithm was invented for the first Tron movie, I think.
Oh, nice reference.
And actually, I can't see that being used in the movie, but it is there somewhere. So let's load something. Here we have an image.
A girl on the side.
Yeah, let's make it straight. And now it's too large in the x-axis. So one solution to that problem is to add a camera, the orbit camera, and make it perspective correct. Yes. There we go.
All right.
Or you can, but that's more annoying and will not work when you have different sizes of the window. You can play around with the x aspect ratio here.
Okay.
But that's really not the right way. You should use the camera to do this. And Kenneth, do you know the difference between JPEGs and PNGs?
Different compression algorithms?
That's true, but not really relevant for real-time graphics.
No, I guess not.
PNG has a distinct advantage over JPEG.
It's a newer format, but...
Yes, but JPEGs cannot pack alpha channels, but PNGs can.
Oh, right. Yeah, of course. I knew that.
So that's very, very, very useful when you're doing 3D stuff. So, but on the other hand, as you mentioned, the compression algorithms are totally different. So PNGs tend to be much, much larger. And this is just an upcoming module in VSXu 040. It loads 2 JPEGs, and one of them should be grayscale, and it should be the alpha channel. So you can do that, for instance, in Photoshop. You can export. So then you get it's more, you have to load 2 files, and you have to manage this on the file system and stuff. But at least you can do it, and that will make for much smaller .vsx files when you use this module.
Create your own alpha support in JPEGs. Nice.
Yeah, and you can abuse that as well. We can load the same image twice and see what happens. We should probably render 2 on top of each other. Yeah, you see it is semi-transparent.
Right.
The darker areas are more letting through the background more.
All right.
More translucent. So it works, but it only uses the red channel for that. So make sure your JPEGs are grayscale. Then also the JPEG format can optimize away 2 channels. So only grayscale. You can in Photoshop you can select that when you export. Okay, I think that covers loading, and Now we should take a look at the real-time stuff. So let's basically start from the beginning here. We need a texture rectangle again connected to the screen. And then we need texture buffers. And there are 3 buffers here. And we will start with this one, a render surface single. In previous versions, I'm now running version 040 here of VSXu, so it's not released yet. Those 2 modules up here are new.
Okay.
But we will start with this one, because this is a general purpose, can do anything module. These exist for the sake of optimization in special cases, so we can show those later. So in this case, we see nothing, and we will use the good old colored rectangle again. So this is what we get. So
yeah, that's a rectangle, all right.
Yeah. So what happens here? Yeah, it renders onto this texture, which is then rendered to the screen. Maybe this is more obvious when we decrease the resolution. Yeah.
Whoa.
So, you know, there have been lots of 8-bit style games lately.
Yeah.
Here you can create your own. Like this. Okay. Let's just put this to viewport size. That's then it will adapt to the size of the window or the screen, and that looks really nice. And here we have the parameter called support feedback. We are going to exploit that right now.
Okay.
So let's make a loop.
Okay.
How did we render here? And let's see if we can get this to work. Yes.
Whoa.
There we go. Feedback loop.
Right.
That's really hard to see on the Google Hangout, but since it's drawing on top of itself, and the frame rate is 60 frames per second, the most dark area is lagging behind slightly, actually. And now this doesn't look nice. We need different texture filtering here. We should do linear.
And what does that accomplish?
That makes it smoother.
Oh, right.
Especially when you do this or something like that. So let's make this thinner, and we'll render another one. Yeah. Yeah, you can do lots of effects with this. And you can also draw multiple copies on top. Like this. For really strange things.
What are we seeing now? There's 2 greens and 1 red?
No, it's drawing on top of itself twice with 2 different texture rectangle modules.
Okay.
You can put one below and one above. So this is the order things are being drawn to the render surface single here. But let's break this some more.
Whoa.
That looks nice. Unfortunately, when I make this blue, there are really no blue colors because one line is red and one is green, so we see nothing.
Yeah, right.
So let's make one white instead. There we go. And some more alpha, perhaps. Yeah.
Whoa. Interesting.
So let's hook up an oscillator. Oh, too fast. Too fast. Okay. And there is actually a module which is also new in version 0.4.0 of VSXu, if I can find it. Where is it? Nope, not that one. This is the one part we didn't rehearse.
Of course.
So say something funny.
Yeah, I'm just looking at what you created here. Looks like some form of wormhole illustration from a random sci-fi show from the 80s.
There we go. Plain UV distort is.
Did that just stop and change rotation?
Yes, it's a sine wave.
Oh, right.
Where did I put this one? It's called plain UV distort, but I want to find it in the tree. Actually, you know what? I think it's a mesh. And the generator or solid. Yeah, here we go. Plain UV distort. Great.
Okay, what does this do?
Yeah, we were actually not going to talk about meshes in this episode, so we will just use it for now in a very basic way.
All right. More to come then.
Yes. So let's draw that on top. And I think we need let's disconnect that. So maybe you have seen these visualizers, that music visualizers that are the most common ones.
Windows Media Player.
Yeah, that one has, and for some reason this one broke down, I think.
Couldn't take the pressure.
Yeah, looks like it. It's pretty new, so. Let's recreate it.
Was the icon in the plain UV distort? Is that a miniature of the effect? No, it's just a random.
No, it's
a
not.
General.
Yeah.
Right.
It seems to break when I somehow. No. Let's leave that. I need to debug that some more.
All right. Leave it for the mesh episode.
Yes. This is good enough.
That is a cool effect.
Although simple. But yeah, there is also another useful one that we can take a look at. This
Blur.
is blur, yeah. So with that you can create glow. Let's disconnect this for now.
Okay, but you're leaving something in?
Yeah, I'm disconnecting everything. Here we go. Textured rectangle is what we need. But let's create a new one. Nope.
There it is.
Yeah, so let's restart with one of these. Actually, let's reuse the old one, this one, white one.
Right.
Okay. Like that. Then we have blur, which is a texture post-processing effect. And
Oh.
it blurs it. And I usually use viewport size divided by 2 for a nice blur effect.
Okay.
And then we can use the blend mode again. And then we clone that one. And we draw that. Like so. And that replaces the background, but then we change the blend mode to 1. And there we have glow.
Oh, nice.
And that's really useful to make a lot of things look nicer.
So you have one with sharp edges and you have one behind which
Yes.
is blurred.
Yeah, so if we look at the path here, we draw this contains the texture with just the line.
All right.
And then the texture, the image itself is blurred and drawn, and then it's also drawn
Just
directly
drawn.
from here. Yeah.
And the blurred one is drawn first. With the
in this
unblurred
case,
one.
it doesn't matter because the end result is the same because the color is just added because the destination blend is 1 here.
Okay.
So then you can set the start value to make the blur more or less blurry. But then you see down here you get artifacts here.
Yeah.
Small boxes. So this is the downside. This is kind of an optimized way of doing blur, so it's not a real proper Gaussian blur because that would require lots of iterations, and yeah, we can't do that in real time. So this is using an optimized version. But one trick that you can do is to simply use a lower resolution texture, as you can see.
Mm.
In some cases, that can also produce. Sorry?
And for the blur, that doesn't matter.
No, but sometimes you can get artifacts anyway, because yeah, you can probably see it here. But that depends on what you're doing. I mean, if it's a fast-moving thing, then it doesn't matter.
Right.
Yes, so that's also very, very handy. Do we have anything else to play with? Maybe we can just take a quick look at these different types of color buffers.
The new ones.
Yeah. Because this one here, the render surface single, inside in the code, it's actually not very optimized. It does a copy of the entire screen actually. So if you need feedback support, then you can only use this one. These ones, when you do feedback, it's undefined actually in the OpenGL standard. So don't do feedback with these two.
Okay, what happens?
We actually tried that before. Something happens, but it's not the right thing. Hopefully your drivers won't crash. And
Ooh, all right.
so if you
Don't
are
do that,
Intel
then.
drivers, don't even think about it. Also, on Intel drivers, I have had problems with nested when you nest these. So if you have a train when you want to, yeah, you're rendering on one of these with the result of one of these. So if we do something like this, and then you render, you would render like this. And that doesn't really work on Intel drivers, or at least it can cause problems.
All right.
So now I'm drawing in two of these in after each other. Okay, that was a side step. These ones are doing the same thing actually, but faster. So if you just need to create a dynamic texture, then use one of these. Render surface color buffer, render surface color with depth buffer. This one doesn't have a depth buffer, and in this case we don't need one. So let's just hook it up and see what happens. Viewport size. And now we see something funny.
Oh.
Can you spot what it is? We're just drawing and drawing. Yeah. It's not clearing the screen actually.
Oh, right.
So this one, texture here, won't be cleared. And that's also an optimization actually. And in order to do that, there is a module for that, of course. OpenGL modifiers, buffer clear, which needs to be put in between the drawing and that one. And by default, it does nothing. So if we set that to yes, we get the previously expected result.
Yeah, right.
So in some cases you don't want to clear the depth buffer, for instance, and then you maintain this to no depth buffer. Okay, this here doesn't even have a depth buffer. You would use this one. And maybe you don't know what the depth buffer is yet, because we were going to discuss that in the next episode with the meshes and stuff.
All right.
And we will probably use this one again in the next episode. But you can, if you have two of these, you can have them share the same depth buffer, which is useful because maybe you want to draw something here and then add glow to this, but not to this. Yeah, it doesn't really make sense right now, but we will get to that and show an example.
Okay, fair enough.
But if you know what a depth buffer is, this is very useful for a lot of tricks. So that about covers this lesson or this episode, I think. We've done lots of random stuff, and the intention isn't really to be that educational, but at least show what you can do and inspire you to use VSXu and play with it.
As long as you don't give me homework, I'm fine.
Do you want homework?
No.
Right, so you won't get homework.
Thank you.
But you get a tiny bit of homework to try to figure out something to do with spheres for the next episode, because we are going to do spheres a lot. If you can come up with some kind of pattern to, yeah, let's say you can arrange 5 spheres in some order on the screen.
Okay.
To make a basic shape, and we will do that, and then we will play around with it, see what we can get.
Hey, that sounds exciting. That kind of homework I can do.
Okay, good. Then I will look forward to that. And yes, we hope this was fun and useful. So if you have any questions about anything here, please leave a comment. We covered lots of things, and I bet there are some questions. So yeah, have fun, and until we see you next time. So bye bye.
Goodbye.